Okay. Welcome to session three, Machine Learning Extended. Today, the speakers are going to be Avinash, who is the part of the technical team at DSC, and me, Bhuvanashri, who is a co-team member. All right. So this session, we will go into a little more detail about what machine learning is. It is advised that you have attended the previous two sessions, so I'm hoping that you were there. And also, even if that's not the case, no worries. We will be diving deep into each of those concepts that we had studied earlier. Okay, so before we jump into today's session and discover new terms and terminologies related to machine learning, I'd like to do a quick review. So, over the past two sessions, I would like you all to answer what have you understood about machine learning and what do you think that machine learning is? So, feel free to unmute and answer. All right, so let me help you out there. Okay, Nikhilesh, go ahead.
Yes. Uh, According to me, machine learning is a way of teaching a machine using data by applying few algorithms.
All right, that's pretty accurate. So, why is it important? So, right now there was a long pause. I think many of you were trying to, grab all the concepts that you have learned in the previous session and trying to put together a definition. But this was exactly the point of this slide. When someone asks you what machine learning is, either they're trying to test your understanding of the subject, or it's going to be in another situation. So when you're going to be out there working as a data scientist or a machine learning engineer, there are going to be situations where professionals and executives are going to approach you with a problem at hand, and they have loads and loads of data and a problem, and they want you to solve it through machine learning. But usually, their understanding of what machine learning is and what it's capable of, keeping in mind the limitations that machine learning offers, is pretty low. They do not have a good understanding. So, as a data scientist or an ML engineer, it is your duty to make them understand what exactly machine learning is and what are its capabilities. So, let me help you out here. So, the next time someone asks you what machine learning is, you shouldn't think that much and be able to put forward or display the clarity of thought that you do have in your head. So, one definition could be machine learning systems take inputs to make useful predictions and decisions about previously unseen pieces of data. This You know that you have in the previous session we had one machine learning. We trained a neural network model to identify what are or differentiate between the blue and the orange dots, or you could say classifying between cats and dogs. So this is what this definition says. Another definition is machine learning is a specific field of AI where a system learns to find patterns in examples in order to make predictions. So you do see patterns, predictions, these are the keywords. So ensuring that your definition or your answer to that question has these words is what is going to ensure that you convey your idea well. And this is one more definition. Computers learning how to do a task without being explicitly programmed to do so. And this actually covers, or it's a more broader covering aspect wherein we're talking even about artificial intelligence. This is exactly what happens there as well. Okay. So, in the previous few sessions, you might have been introduced to what machine learning systems can do and what they are capable of. Few of the examples are labeling or classifying data. This comes under, so you can say, image classification, or trying to identify different kinds of objects in a given image, and so on. Then we have predict numerical values. So you can think of the case when we were predicting the price of a house. Then we have cluster similar pieces of data together. Maybe this is new to you, but don't worry, we will be introducing this concept of clustering in future slides. Then we have infer association patterns in data. This is the most relatable to the neural networks that we had learned, and create complex outputs. So we have a specific type of neural network called as GANs, or generative adversarial networks, that actually generate new pieces of information. It can be creating its own image or its own illustration. So that's what they mean here by creating complex outputs. Now let's move on. So that now we have an exercise. So every time that you read an AI or machine learning article, there are three essential questions that you need to ask yourself, and or you need to be able to critically analyze the article. And in order to do so, you need these three questions. So if every time you read an article, so these are the three questions that you should be asking yourself. The first one is, would a traditional programming solution be more efficient? Now, do remember that when someone's writing an article, they're trying to project that their solution is the best, or an AI or an ML based solution is the best. And so it can be quite biased. But as a reader, it is your responsibility to find out that, okay, can traditional programming be more efficient in solving this problem? The second question is, could a human perform the same task in less time? Well, the very purpose of an AI or an ML model was to simplify our tasks. And thus, this should be the obvious next question. If we are able to perform better solving this question, solving the problem, then of course we shouldn't be going for an AI or an ML based approach. And thirdly, what are the benefits of a machine learning model in these instances? So we need to weigh out our different advantages and disadvantages of traditional programming, as well as what a machine learning model can offer. So I have a quick activity for you guys. It's a 5-minute activity. What you can do is search up any AI or machine learning article that you want. And as soon as you find one, do put the link in the chat box so that we have a collection of the different articles um, from that you have found out, something that you have been interested in. So AI is large spanning and it is related to multiple domains. So maybe you're interested in biology and medicine. So type in the words AI and medicine and check out an interesting article. So right now, I'll be giving you 5 minutes and you can go ahead and find an article. And as soon as you find one, put the link in the chat box and try to answer these three questions. So I think y'all can go now and start hunting for the article. Okay, so if you're finding it difficult to find articles, Nikhilesh has just posted 2 sample articles that you can check out. Um, so you can do your analysis on those as well. All right, I think we can begin. It's all right if you haven't read the entire article. Um, we can come back, and during the break between the first half and the second half, you can continue. And we've got a wonderful collection here of different applications of AI. So you can keep putting the links if you're still finding it. So, but we'll move on for now. All right. Now, we did mention, you would have obviously heard these words, supervised and unsupervised, because we did keep mentioning this in the previous sessions. But let's have a more formal introduction to what these exactly are. So machine learning can be broadly classified into 2 categories, and those are supervised machine learning algorithms and unsupervised machine learning algorithms. Now, like it says on the screen, in supervised machine learning algorithms, the training data that we feed into the model is labeled, whereas in the unsupervised machine learning algorithm, the training data is unlabeled. Now, what is labeled and unlabeled? So let me give you an example. So the example over here is that of stop signs. So these are stop signs from different parts of the world, and we have a label below them. So this is one stop sign, this is stop sign number 2, this is another stop sign, and so on. Whereas the one on the right side, we do have different signs, but we don't exactly know what they are. So this is exactly what we mean by labeled and unlabeled. While feeding it into the model, we give the model information about what each example is. Now, if you recollect, we have our data set that we use for training our machine learning model, which has multiple examples and features. So the examples are the rows and the features are the columns. And in supervised machine learning, we have a data set in which one specific column is called as the label column. And in that label column, we tell the model what each example is. So for the example of classification between a dog and a cat, we do give it a label. So every time we give different features of the animal, like the weight, the fur, the number of ears, eyes, and so on, we also tell the model that, okay, these are the different features, and corresponding to these information, the label is that of a cat. So we tell the model what it's exactly seeing. But in the case of unsupervised machine learning algorithms, we do not exactly tell. And you might be wondering, where are they exactly used? What can we do with unsupervised learning when we're the actual point of training a machine learning model is to help it identify situations. So, what's the point if we can't label something? So let me give you an example. In the previous slide, we had mentioned something about clustering similar pieces of data together. Well, this is exactly that. So let's take an example. So you have a website, say a retail website, and you want to be able to target a specific customer group that are contributing the most to your income. And but you do not know who these people exactly are. So, what is going to be the advantage of finding this out? Let's say that I have a bunch of teenagers visiting my retail website and they're searching for gaming consoles and they're looking at different, the latest gaming hardware and the gadgets that go along with them. So I do not know that these are the people who exist, but I do know that I have a group of people who are contributing a lot to my income. So the next time, if I'm able to identify these group of people, the next time I'm going to give advertisements and I'm going to give offers to them so that I can increase their rate of clicking on an ad and again leading to an increased income. So, in unsupervised learning, what we're doing here is we do not tell the machine learning model that, hey, I think I might be having these different types of groups. Tell me who they are or which group they belong to. Rather, we throw the data at the machine learning model and ask it to group them. And that's how we're able to derive different kinds of interpretations from our model. So, moving on. Okay. In our second session involving neural networks, we did talk about a term called as loss. There, it was just a number. It was a number between 0 and 1, and I had explained that it was indicative of how well your model was doing. So let's dig deeper into what exactly loss is right now and try to approach it from a more visual perspective. Right now, the task at hand is to model this given data set. So these are the different data points. And as you know, each point has two coordinates and each of the coordinate corresponds to a feature. Right now, it corresponds to the square feet of the house and the corresponding price. So as you can see, we have increasing square feet on the x-axis and on the y-axis, we have the price, and we have these different data points. So our what is the purpose of this machine learning problem? Well, given any random square feet, I want to be able to predict what will be the price of the house or the price of any such real estate area. So we are given all these examples and we need to predict a line that is going to best model this given data set. Or we want to place a line in such a way that the next time I'm going to give it a specific square feet amount, it is going to be able to predict the price as accurately as possible. Now, you might be wondering this, and by the way, this is called as linear regression. We are trying to predict a price that is a number, and it's called linear because we're trying to fit a line to our data set. Now, what is loss? If you take a closer look, you will be able to notice that this is one. This is the output of one machine learning algorithm. This is another. This is another, and so on. But if you look or give it a closer look, you'll be able to observe that this line seems to be modeling the data very well. That is, the distance between the actual point and the line is less in this case. And if you see, the loss for this model is less as compared to all these models, because these data points are at a huge distance from the line as compared to the points on this graph. Now, what does this indicate? The number over here that you're seeing, 81,352, is basically the addition of all these distances. So what is better for us? We want to achieve this distance, or the difference between the actual point and the line should be as minimum as possible. And that's what we're trying to optimize. So you could say that this model has the least loss as compared to all the other models. Hope that made sense. Now let's move on. Okay, this is another recap of the session of a few terms that we had in that we introduced in the previous session. One is features. So in the case of predicting the price of a house, we have features like the location, the number of bedrooms, or size of the property. But we also have features that are actually not going to help us do or achieve our result of predicting the price. And those are the number of light switches or the color of the house. In no way are they going to help us in predicting the price of a house. Now, for such a simple example, it's very easy for us to identify those features that are not going to help us get or find our final result. But as the complexity of our problem increases, we wouldn't be able to zero down on those features that are not contributing well. And for that, you need to do something called as data analysis. You need to be able to analyze your data, draw different visualizations from it in order to come to a conclusion of what features actually affect or drastically affect your final result. And sometimes you can't even do this before you train your machine learning model. You might realize that some features are redundant and unnecessary only after you train your machine learning model. So let's move on and look at another example. Recommending which video a user should watch next. So what could be the features here? We could have the topic, which is very obvious. Then we can have the popularity of a video or the number of views. Then we can have the creator. Now let's analyze these two features. That is length of a video and age of a video. Do you think that these two features would help us in recommending a video? It depends on the situation. Well, if you ask me, I think it does. The more recent a video is, the more likely that it is relatable. You could think of it that way. And the length of the video too. So based on the user's activeness on, say, the video streaming platform, we can say that, okay, looks like the user tends to like shorter videos. So let's predict a shorter video. So these two features do actually contribute significantly to our final result or what we're trying to model. All right. Now here comes an interesting slide where we're going to be critically analyzing different situations or different cases where we'll be trying to model a machine learning solution to a problem. These are five very, very important questions that we need to be able to answer while trying to come up with a solution. I will be going through a few examples to get you comfortable with these set of questions. And even in the future, after this session or any time that you're building a project, these are questions that you need to ask. Now, the examples of machine learning problems that you're going to find online are going to be very simple, like those of predicting the price of a house or classifying between a cat and a dog. These questions are not really applicable to those situations when we know the output and when the problem has actually been dealt with and analyzed to a very huge extent, given the popularity of ML in the past few years. But in the real world scenario, when you have a problem that you've never seen before or heard before, you need to be able to analyze it critically, and that's why these questions. Okay, let's look at the first scenario. A baker would like to optimize pricing of cakes in their bakery depending upon previous pricing, cost to make, and time of year. All right. This seems pretty straightforward. It's a regression. We know that regression is used for predicting the price. So we kind of have an idea on what machine learning algorithm we need to use, but you shouldn't just stop there and start coding with all the data that you have, but rather answer these questions. So let's look at the first question. What about the scenario makes it suitable for machine learning? Well, the fact that we have multiple variables. We have variables that are obviously listed here. One is previous pricing, cost to make, time of the year. These are variables that are actually helping us in modeling our final result. Then let's look at the next question. What is going to be the benefit to the business? Well, if you are going to able to find the most optimum price, you're going to ensure that your profit is going to go up, and at the same time ensure that you're selling as many cakes as possible. So that would be the benefit to the business. Let's look at the next question. Would a human perform the job better? Well, this is actually a very interesting question, because you know that in India, all these small bakeries, I don't think they go after a machine learning solution, or they want, or half of them don't even know the existence of AI because of multiple reasons. But I don't think they do leverage on AI or machine learning to better determine the price of their cakes. They go by experience. They do what is called as the actual intelligence. They use that to estimate the price of their cake. But we know that in order to be able to detect patterns that we can't detect, that's where the machine learning algorithm is going to be helpful. Let's move on. What are the inputs to the system? Like I said before, the inputs are previous pricing, cost to make, and time of year. And how could the ML model go wrong? Now, this is interesting. And this is something, and the points that I'm going to discuss with this question is something that you can extend to other machine learning problems as well. You know that your machine learning model is going to do only as good as the training data that you give it. So let's say that the ML model that I'm training over here is given a data set that is only taken from a specific period in the year. We know that during Christmas or maybe during wedding season, the uh, the sale of cakes are going to be very high. And let's say I take the pricing and the cost to make of the different cakes only during that period and train my model for it. Well, that is going to mess up, because if you're trying to predict the optimum price for your cake for another point in the year, it's not going to predict the price well, because we know that during when the demand is high, we're going to keep higher amounts of we're going to keep a higher amount for our price. Whereas when it's going to be a dry season, or when we know that we don't expect much customers, we're going to keep a lesser price for our cake. So we need to be able to give it or provide the ML model with um, as best possible of a database, which models every different situation, and so it's able to predict future prices as well as possible. Okay, another example. An ocean conservationist would like to track fish populations over time. So what about the scenario makes it suitable for ML? Well, the fact that again we do have multiple parameters here. um, we um, we know that the ML model is gonna take into or consider the different patterns that we as humans can't identify. So that's what makes it suitable for machine learning. Then what else do we see? The next question: what is the benefit for the organization? Well, you can say that by tracking the fish population, we will be able to know which fish population is declining and thereby take measures to counteract that. Now, let's move on to the next question. Would a human perform the job better? It would be a very slow process, and even experts make mistakes and have to refresh their knowledge over time. And hence, I feel that machine learning is the best for this job. And let's look at the next question. How could the ML model go wrong? It could go wrong in multiple different ways. If the data is not diverse enough, a fish could be misclassified. Um, Fish are not homogeneously distributed. The count could be off depending upon the sampling, and so on. Okay, and what are the inputs to the system? Well, the type of the fish, the region that they're found in, time of the year, the number of fishes, and so on. So let's move on. Okay, this is an interesting one. An online brand influencer wants a model that can predict the number of likes that a particular post may get. Okay, so this seems more easy, I would say, because it's a very pretty it's pretty common for the people online to be able to gauge their audience and try to make conclusions from them. So let's see what we can conclude or how we can analyze this problem. So, what about the scenario makes it suitable for machine learning? We have lots and lots of examples, and if you're a popular brand influencer, then you do have many people coming and interacting with you, and you know how they are, how they interact with you, and different parameters related to them. And you can also run experiments to see which variables have an effect. So this the advantage that we have in terms of the amount of data that is available is something that we can definitely leverage in this case. What is the benefit for the business or the individual? Well, the obvious benefit is that we're going to be able to reach far more people and have them interact or engage with the brand and online brand influencer, and that's the benefit. And would a human perform the job better? So, with so many variables, especially when it's a human being interacting online, we have so much of data collected about us and varying data. A human could get a sense for optimal times for a specific situation, but it would become complex if the product or the influencer audience, etc., were changed. So, we are dynamic. The audience online is ever changing, and we are bound to react and behave in different ways. And so it becomes difficult for a human to keep gauging how our actions and behavior is going to be. So I would say that it is a human could not perform the job better. The next, what are the inputs to the system? So potential variables could include time of the day, the person posting, the brand, the product, the social network, the friends that they have, and so on. And how could the ML model go wrong? Well, if trained only for a specific type of post or product, it might not generalize to another scenario. So let's say the brand influencer, let's say he posts about shoe brands or different kinds of shoes. And also along with shoes, he also posts different kinds of dresses and attires on his social media platform. But what if I'm going to train my model only on the audience that interacts with the post on shoes? Well, that's when the ML model can go wrong. And if the training data is for the wrong demographic, the pattern might not be relevant. So let's say that we take into consideration features like the gender, age, marital status, etc., but we do not consider other features about the person. Well, your model is going to be biased. If I'm going to only feed in the gender, age, and marital status, it's going to behave or try to predict something that's going to be along these same lines as well. And that's how your ML model can go wrong. All right. So we've looked at multiple examples, and now is an activity for you where you have to create your own scenario. Or you could say that you can come up with a situation that you have seen where ML is applied and ask these 5 questions. So take your time, 2 minutes of time, and come up with a scenario, and let's discuss how you can answer these 5 questions. So anyone willing to answer can raise your hands. any kind of situation that you feel machine learning is used, and we can analyze these 5 questions for that. Okay, we have Nikhilesh who's raised his hand. Anyone else? Okay, folks, keep in mind that we are looking out for an active participation. We are very diligently noting down all of your names, even if you speak up once, twice. People who are posting on the chat box, we're noting it down so that we will be able to do justice to you while handing out our badges at the end. So don't feel hesitant to answer, and it does not have to be the right answer. So feel free to let's discuss any application that you know of. Okay, Tarak Ram. Yes, go ahead, Tarak Ram.
Yeah, eye tracking, can we have a ML model? We can have a ML model. So when
Okay,
we plot, when we can, so for the eye tracking, how it, the sense, we have like, we are seeing a constant object or constant thing if we guess. Okay,
okay,
so we'll be predicting the points of the eyes.
okay.
With this we can apply an ML algorithm so that for an application like for like a deaf or dumb person, it may be applicable, right? He can use only eyes with eyes to communicate.
Yes, yeah,
So we can use, based on his movements, we can predict what he want, like that. Apply ML over there.
yeah. That's nice. And so our machine learning model, you're saying that we're going to train it to track our eyes. So where do you think it can go wrong? Like, is there any situation when it's going to go wrong?
Yeah, there are some couple of situations where it may go wrong also.
Okay,
So when a person, like some persons have their eyeballs at the, not in the middle, and some to the right of the eye, right?
okay,
While predicting that person's like position of the eye, what where he is seeing, they may have they might have a model get gives us wrong output
yeah.
predictions like that.
Okay, so again, I think giving it more training examples will solve that problem. And also, every system is not perfect. So, thank you, Tarak Ram. Um, Nikhilesh, would you like to? Okay, yeah, go ahead, Nikhilesh.
Yeah, I just want to add on one more point to what where ML can go wrong.
Okay,
One is the data set. The other thing is where we are collecting the data set. If we collect the data set where the eye is like comparatively different from others, then we might have a model where it can go wrong. So we should have a diversity even in collection of data, like different places.
okay. So you mean like even the color of the eye and the
Yes.
skin tone can also bias the model?
Yes.
Okay, that's a very interesting observation. Shravan, I think you
I
have.
think in
Okay,
beauty it goes wrong with machine learning, like some
okay,
fashion programs.
yeah.
I think, but not sure.
Okay, what is the application here? I think I didn't understand.
Like in fancy dress competition,
Yeah.
like modeling, some facial
Okay.
won't
What are you
predict.
trying to predict or classify here?
Like in example in 2016 for an international beauty contest, which was to be judged by machines. Thousands of
Okay.
people from across the world submitted their photos,
Okay.
but
So
in that it went wrong, like racism.
okay. So the model was biased. All right. That's a very interesting
Yes.
example, Shravan. Okay.
Oh, thank you so much.
Yeah. Yeah. Anyone has doubts, you can ask them right now. Feel free to unmute yourself and we can have a discussion. And also, if you would like to share different scenarios where you think ML can go wrong and can be used, feel free to unmute yourself. Oh, yes, Aditi. Okay. This is, I didn't open the chat box, but yes, predicting COVID-19 highs and lows also could be a very nice situation where ML can be used. Yes, Sri Lekha, sales prediction also a very, very important application where ML is used and leveraged. Traffic management. Yes, Akhilesh.
Okay, so before we start, I expect you guys have a notebook beside you because we'll be going through some terms that are really important and will be used in the next sessions. Problem framing. Machine learning programs learn from data, but how do you know if it is going well? In this session, we will discuss how to frame a machine learning algorithm and understand whether your algorithm is successful or not. What is supervised machine learning? So, any one of you can revise it as just before the break, Bhuvaneshri explained it. Yeah, you can raise your hands. All right. Yes, Daiban Mukherjee, you can.
When there are certain labels in the data, like it is specifically categorized.
Exactly, you're right. Okay, so supervised machine learning exactly means like we have labeled data and where the algorithm is already given data which consists of the input as well as the output. So the algorithm detects or maps the relation between the input and output through several data and then trains itself. Okay, so as we said, we'll be going through some terminologies that are very important. And the first one among them is label. So what exactly is a label? So it is actually like if you relate this to a linear equation, y is equals to 2x plus 4, then y is the label, the output. Next up, we have features. So features are basically input variables. And let's take an example. Like if we would have attended the last session, you would have seen about the quick draw, where we draw different objects, and then according to that, the machine learning algorithm predicts whether it is that object or not. So let's take the example of a carrot. So here, the carrot had several features such as the triangular shape of the body, or the bushy top, or the marks on the body. So yes, here the features are the length of the scars, the height of the bush, and the shape of the body. Example. So taking the same example forward, each and every drawing of the carrot that was shown on the website, the dataset is an example. The machine learning algorithm learns the features from these several examples and gets trained. All right. So now there are two types of examples that are used in machine learning programs. The first one is the labeled dataset. It can be related to the data that is present with the quick draw game. A labeled data means it has the features as well as the label regarding that example. So as we have both input and output, we use these type of data for teaching the machine learning algorithm. Unlabeled data. So this is the second type. So how is it different from labeled data? It has the features. Features means the X variable, but it does not have the labels. That is the Y variable, the output. So these data can be related to the drawing that we were drawing on the site. So the machine learning algorithm doesn't know what it is. It's just getting the input from us. So what it does is that use the features that it got trained previously and applies that into our diagram, our drawing, and classifies it. Model. A model uses these examples. It's basically an algorithm that maps the relation between the input and output and learns these features. All right. So now we have a task for you. In this, you'll be given an article to read. It's about detection of skin cancer. And after reading, you have to tell us what all things can be filled from that article to these given blanks that are in the screen, like the label, features, examples. So you'll be given 10 minutes. The link will be in the description in a few moments. So let's start. All right, so let's move forward. I think you might have read, or even if it's okay, even if you have not completed the read. All right, so what do you think you can fill in these blanks for the label? Okay, so for the label, we can take as the type of cancer, like it is the malignant cancer. Okay, yes, Srilekha, as you said, yeah, you're right. It can be taken as skin lesions, the type of cancer. And okay, so now let's move on to the next one. Feature. So what all can be the features?
The feature is definitely what the skin looks like.
Okay. Yes, you're right. So the features can be the irregular types in the skin, or like how it looks, the in the normal difference in normal, difference from the normal, or the diameter difference, the color. Yeah, the thickness, radius, and all. All right. So what about examples? What examples are being used here for the machine learning model?
Different types of cancers, they have shown that what type of the skin is associated with it.
Okay,
Like
so
what type of skin lesion.
what is the data that's used?
Different types of these, what was it called? Wait.
Yeah, we can say some kind of images or
Yeah,
scanned report.
the biopsy images, the
Yeah,
approved biopsy images are used here, so that only high quality ones, so that the machine learning algorithm does not get. They've used deep learning here, so it does not get confused.
exactly. So for examples, we are using biopsy images.
Yes, only the verified ones, but in the article they've also written that they had to translate a lot of it because there were different languages also in it, and they didn't have a language processing algorithm installed in it, and that would make it more complex. So
Okay.
they had to, yeah.
Yeah, that's this. I'll give you a short fact. Like what all things we are doing, they did before the implementation of machine learning model, like changing the data, changing the names, making it into the similar language. That comes in the part of pre-processing. That means you are setting the data in a proper manner. Okay, so now for the labeled example. So what can be used? What are used in the labeled example category? Yes, Srilekha. Yeah, you're right. The output is actually whether it's a cancerous or not. That's the final output.
In the article, they wrote that there was no specific data set for this thing from before, so they had to create their own data set. So I think the labeled example would be any type of like, what
Yeah,
should I say?
actually, I've mentioned just before because you said the data was not proper, so only confirmed images were being used.
Yeah,
So the label here is the confirmed images that they are using.
okay.
Yeah. All right. So for the unlabeled example, what is used? Here we use like whenever we want to check somebody or while testing the model, we take some unknown sample. That's comes under the unlabeled example because we don't know whether that person has a cancer or not. So no output, we only have the input. And the final output, yeah, whether it's cancerous or not. All right. So now let's go on to some steps that are used for framing a particular model and completing it. Okay, so we have a few steps. So the first step is framing the problem. So here we exactly need to know what the problem is. Like if we take example of the traffic, and what do we want to know if whether will be traffic there tomorrow or not. So that's a particular problem. And then we go on to the next step, make a hypothesis. We assume a condition, like we can assume something like there will be traffic, will there be traffic in the time from 9 a.m. to 1 p.m. and we assume yes it is, and then we move on. Or another example is like the weather forecast. What could be the weather forecast in a particular time? We take a hypothesis that it should be this or not. And the next step is collection of data. So in this example, as for traffic, we'll take the historic traffic data in particular regions, in several regions at several different time and several weather conditions. So the next point is test hypothesis. So we have whatever hypothesis we made in the second step, we test it, and after collection of the data, and then we check it whether it is matching or not. And the next step is analyzing results. So after the test hypothesis, we check whether the result is like matching or not, or even if we have already a model being used, we can check that whether the current one that we are working on is better than that or not. And the next step is reaching a conclusion. So here it can be like completely a point that we can't use this, or we can use this, or maybe we can some other conclusions can be we can remove these features. Like some features are unwanted and some features are many but very really important, but we may not be using it. So in the next refining method we can use those features. So the next one is refine and repeat. So no model can be completed in one single loop. We need to refine it more and more to make it more accurate and proper. All right, we have a problem here, a problem framing practice. So the first condition, we have a situation here. So your landscaping business is hiring people for the fall season. You want to predict how many leaves will fall from a tree each day. So you hire the right number of people to clean up. So the clear use case. What is the clear thing that we want the machine learning model for? So what exactly we need is to find the number of leaves that fall down from the tree. And the second one is to know the problem. So the problem is that we have to hire a few people for workers to clean those leaves, but we don't know how much leaves fall in a particular day. And if we know it, then we can accordingly hire as much number as needed, not going for less or more. And the third, you have a lot of data. So how would you get data on leaves falling from trees? Would you be able to get it from every type of tree in the given area? And what factors might influence leaves falling? And the next point is predictive power. So it is even possible to reliably predict what you're hoping to. Is it possible to predict if it is going to rain on a given day, or it matters? Okay, and the next one is aim to make decisions, not just predictions. So here after the machine learning, the model is complete. It predicts the output, but it should be such that we can conclude to a particular decision or not a confusion. So is this a well-framed problem for machine learning? So checking to these conditions, yes, we have a clear use case, we know the problem, we have the data. If we have the data, it is a proper ML problem. All right, so next one is for you folks. The problem here is a beekeeper wants to analyze pictures for their honeybees and identify the role within their colony. So what is the clear use case? You guys can give any suggestions. Like, what do you think? Okay, I'll repeat the problem. So the problem here is a beekeeper wants to analyze pictures of the honeybees and identify their role within their colony. So how can it be used for machine learning? It's all right even if you are wrong, like you can try it out and it will definitely help you.
Avinash, could you
Yes.
explain the clear use case again? Like I didn't get it that much.
Okay. So the clear use case exactly means that what is exactly the problem? Like where can be it used in the problem? If in case if I go back, wait, let me show you. In the problem of the landscape business, this one above falling the leaves, we have a clear use case. We have a particular area where we have to use the ML problem, like the number of leaves falling. So if we know the how much leaves are falling, according to that we can hire the workers and our problem is solved. So clear use case means we should know exactly where to put this model and what data to get at. Did you understand?
Yeah. So in the next problem also we have a clear use case then.
Okay, so what do you think is the clear use case here?
See, the worker bee, the queen bee, the drones, they all look different. Plus, each of the honeybees, like there'll be certain amount of variation. They won't look exactly the same. So,
Okay,
even though I think that this problem could be better solved with a procedural, not procedural, nah, what
the
should
traditional way.
the traditional way would suffice in this, because it's just three different ways in just three different categories, and we're putting it into all of them. Like we can use the learning part, that the machine gets to learn that a drone looks like this, a queen bee looks like this, and a worker looks like this. But
Okay, yeah, so here we basically want to identify the roles of the honey bees. Like you have heard of the queen bee and the worker bees, right? So we have to identify in this case which one is the queen bee and which one are the bees which are working. So that can be taken as a clear use case. And the problem is differentiating between the bees, like which bees are working. And yeah, so the third one, you have a lot of data, right? So for that we need to collect data by clicking pictures in different situations, different positions of a lot. Like we need a lot of data for this. Okay, so the predictive power. So in this one, we have to tune our model accurately such that in any situation wherever the bee is sitting uh, inside the hive or anywhere, we have to the model has to exactly identify whether it's a queen bee or not.
I feel the predictive power in this is actually will be pretty easy to predict, because the obvious size difference,
Yeah,
right?
yeah, you're right. And then we have the fifth point: decisions, not just predictions. Model should be accurate enough to like take a particular clear decision than just a slight prediction over it. All right, so let's go to the next problem. Okay, so a teacher wants to predict a student's end of the year test result based on a student's performance on mini tests throughout the year. Okay, folks, so what do you think is the clear use case here? You can unmute and speak. All right, so the clear use case is to detect to actually find the performance, predict the performance of the student in the final exam. How will be giving the exams and what marks he may be getting in the final exam. And to know the problem, this case can be mostly can be used for predicting the consistency of a student, like how is he working, how is he studying throughout the year, is he studying continuously, or has his marks has been ups and downs, or he studies only at the end. And data can be the third point coming. The data can be the test marks, the previous marks of all the exams, or even if you're predicting for the future, you can collect data whenever conducting exams. And the predictive power, yes, based on the previous marks, it has to predict a pretty accurate result. All right, so the last problem is a bit different because we won't be giving any particular tasks or any situation. You have to come up with an organization and any real world organization, and then you have to say like how will they benefit from a machine learning model. Okay guys, you have a few 5 minutes, you can think of that and then answer.
I think I have a proposed, like, I have thought of a model.
Okay, so what's your model?
We have these electricity, the electricity providers, right, who provide electricity to our houses.
Yeah.
Like, so what they do is, I think a lot of people would know this. They have specific. They have specific. Specific. Wait a sec. They have specific tires in which they place each customer. Like a customer would use this many units, so they'll put in this tire. Then customer uses more than that, they'll put in another tire, and according to that, uh, they do their billings. So what they do is they just as by seeing a customer's past usage, they just put him randomly into a one which they think that is a this would satisfy the customer. However, it should a machine learning model should be created in such a way that it sees like how like the customer, what is their usage in the whole year. Like in the summers, like if you stay in a place which is like I stay in Delhi, so it's really hot in the summers and it's really cold in the winters. So in summers we need ACs and in winters we need heaters. Now ACs would consume less power as compared to a heater, because so my power consumption in summer will be a lot less as compared to winter. But if you are put in a tire in which for summer it is fine that those number of units work, but for winter those number of units won't work. But since winter is only three months long here, 3 to 4 months long, that is why they usually put us in the summer. The amount of we need for the summer, they put us in that. However, if we make a machine learning model, what it'll do is it'll see the whole year and it'll see the past years and it'll see a trend. Now according to that trend, what it'll do is it'll keep assigning the number of tires according to each month that we are using. Like in a month like October, it's neither cold nor hot, so in that it can assign a low tire because we have minimum usage. However, a month such as January, they would assign us in a higher tire because the usage will be a lot. So according to that, they can like change the tires so that in this the number of units which go to waste will not happen, and the effective, like not bandwidth, but the effective amount of unit which this company can give to people will be like optimized, instead of just giving tires to people just like uh, an average based thing. Instead they can use this machine learning model.
Okay, that's an excellent idea.
Yeah,
Okay,
I
so
I know I bored the people, but yeah.
no, that was really good. Okay, so in Daiban's case, we have the clear use case as exactly classifying the people on predicting their usage in the future sessions or months, right?
Yeah, each month you assign a different tire, so it'll tell you like next month what to assign instead of making a general for the whole year.
All right. Okay. Uh, I see Srilekha's message. Yeah, that's also a really good idea. Targeting audience, and that's been recently used a lot for getting a particular or a particular field of audiences there who have a same interest. So that's really a good idea, and that's being used a lot here. So that's it for today, folks. I hope you enjoyed the session.